Systems Review 1. ATC Chapter 4. Aim. To review principles of aircraft propulsion. Objectives. Name the basic components of the reciprocating engine and describe the Otto cycle. State the operation of the ignition system. State the causes of and ways to prevent abnormal combustion. 1. Describe the Otto cycle. Engine components. Cylinders. Barrel in which combustion takes place and the piston moves. The exterior is normally manufactured with cooling fins. Typical arrangement on light aircraft is horizontally opposed 4 or 6 cylinder. 1. Describe the Otto cycle. Engine components. Piston. Moves within the cylinder. 3 or more grooves are machined around the piston in which are set steel piston rings. The first ring prevents combustion gases from escaping. The lower rings prevent oil from entering the combustion space. 1. Describe the Otto cycle. Engine components. Inlet and exhaust valves. Fitted to cover ports in the cylinder heads. Inlet valve allows the fuel/air mixture into the cylinder. Exhaust valve allows spent combustion gases to escape. When not open they are held in place by springs. 1. Describe the Otto cycle. Engine components. Spark plugs. Ignites the fuel-air mixture at the correct time. Typically arranged with one at the top and one at the bottom of the cylinder. 1. Describe the Otto cycle. Engine components. Connecting rod. Connects the piston to the crankshaft. 1. Describe the Otto cycle. Engine components. Crankshaft. A shaft designed with a crank for each cylinder. Turns the up and down motion of the piston into the rotary motion required for the propeller. 1. Describe the Otto cycle. Engines typically found on light aircraft are of the 4-stroke type. As the name suggests, it takes 4 strokes of the cylinder to complete one cycle. Intake. The piston is moving in a downwards direction, reducing the pressure in the cylinder, sucking in the fuel/air mixture, also known as the charge. 1. Describe the Otto cycle. Compression. The inlet valve closes and piston moves back towards the cylinder head, compressing the charge. As the charge is compressed, the temperature rises considerably. Diesel engines will use this increase in pressure and temperature to ignite the charge. 1. Describe the Otto cycle. Power. The charge is ignited by the spark plugs, resulting in rapid expansion of the gases in the cylinder, increasing pressure in the top of the piston, forcing it to travel down. 1. Describe the Otto cycle. Exhaust. Just prior to completion of the power stroke, the exhaust valve opens, and as the piston moves back up towards the cylinder head, the exhaust gases are forced out of the cylinder via the exhaust manifold. 2. Operation of the ignition system. The purpose of the ignition system is to ignite the charge at the precise time in order to create a controlled flame front. Most light aircraft have dual independent ignition systems for redundancy and to create more efficient combustion. The ignition system is made up of an electrical source, in this case a magneto, a distributor, high-tension ignition leads, spark plug. 2. Operation of the ignition system. Magneto. The magneto works on the principle of electromagnetic induction. A magnet rotates near a conductor which has a coil of wire wrapped around it, inducing a current. Most magnetos will have a primary and secondary coil. Most aircraft engines will have 2 magnetos named left and right respectively. 2. Operation of the ignition system. Spark plug. operate by providing a gap between the high-tension wire coming off the distributor and earth. All aircraft spark plugs are shielded to prevent radio interference. Most aircraft engines will have 2 spark plugs for each cylinder, one at the top, one at the bottom. 3. Abnormal combustion. Abnormal combustion. Normal combustion can be defined as the process in which the compressed fuel/air charge in the cylinder is ignited at the intended time by the spark plugs, with the resulting flame front spreading across the cylinder head in a smooth, uniform manner until the charge has been consumed. Generally speaking, there are 2 types of abnormal combustion: detonation, pre-ignition. 3. Abnormal combustion. Detonation typically occurs when the pressure or temperature of the charge is too high, resulting in spontaneous explosive combustion. Indicated by rough running, high CHT, or possible engine failure. Contributory factors include expired fuel, operation of carb heat at high power, low airspeed, using fuel with a lower than recommended octane, over-lean mixture, excessive manifold pressure, overheated engine. If detonation is suspected, enrich the mixture, reduce the throttle, increase airspeed, open cowls. 3. Abnormal combustion. Pre-ignition occurs when the charge prematurely ignites, typically caused by a hot spot on the cylinder igniting the charge. Indicated by rough running, backfire, sudden rise in CHT, engine failure. Can be caused by hot spots on the cylinder from carbon deposits, high power settings with a lean mixture, overheated spark plugs.